And finally, we'll take a look at the last section of this unit, complex numbers. We'll give it a relatively superficial treatment. You'll get a lot more of this in your next math class. So what makes a complex number? Well, a complex number is composed of two parts. There is the real part, in this case, the A, and we mean by that as a real number, any decimal, any whole number. And then you have the imaginary part. What makes it complex is there's an imaginary element. The B is the coefficient of I, so it's just a number, and I is the imaginary unit. Okay. Um, and the definition of I is it is equal to the square root of a negative one. Okay. So again, you may go, "Oh, imaginary, what does this mean? That means it doesn't exist. It's not a real thing." Complex numbers are widely used in fields like engineering, physics, and a lot of modeling in mathematics, oscillations, waveforms. So double E's and so forth will use this. This is not completely made up imaginary. It's just maybe I kind of think an unfortunate name for this. Um, so it's something that is used. It is real, but we call them imaginary because we have to use this idea of the square root of a negative one. Okay. And so this is actually very easy to do because if we know with the product rule that we can break up any radical and its radicand into component factors. And so the negative 9 can be broken up into 9 and negative 1, and we can break it into two different radicals, right? The product rule says we can do that. So we can break negative 9 into the square root of 9 and the square root of negative 1. Well, the square root of 9 is 3. And by definition, the square root of a negative 1 is I. So the solution to that would be 3I. So that makes solving many of these really very, very simple if you already understand how to simplify a radical. The square root of negative 75 is really the square root of 75 times the square root of a negative 1. And if we simplify the square root of 75, as you can see, it breaks down into 5 times square root of 3. And square root of negative 1 is I. So thus there's the solution. You can see it written like this, or you may see it written since everything's being multiplied as 5I square roots of 3. Either way, it's correct. So square root of negative 18, you just throw the I component and solve for the square root of 18, which simplifies to 3 square roots of 2, and you would end up with this. Um, Simplify 4 plus the square root of negative 16. Well, the square root of negative 16 is the square root of 16 times the square root of negative 1, which is 4I. And so there's your simplification. I is, think of it as a variable. So if you're going to be adding or subtracting numbers that have imaginary parts, you just combine those together as you would any other imaginary or any other similar terms. Okay, so in a case like this, we can add together the real number. So minus 1 plus a minus 2 is a minus 3. 5I plus 8I is 13I, and thus you're done. So you can take a look at these solutions here. Just be careful when you have that negative sign. Remember, you're distributing that negative sign through. So minus 1 plus 6 is a positive 5. Minus a minus 6 is a plus 5. And then minus 2 minus plus 5 is really a minus 5 when you distribute that negative sign. So minus 2 minus 5 is minus 7I. And there's your simplification. Okay. Now, if the definition of the square root of a negative 1 is equal to I, then if I square, so if I have I squared, so the question is, what is I squared? If I square I, obviously I get I squared. But if I square a square root, the radicand always comes out. So by definition, the square root, or excuse me, I squared is going to be equal to -1. So whenever I'm multiplying these terms and I end up with an I squared term, I'm going to replace I squared with a -1. So for example, if I multiply these two here, I get -36I squared, which is really -36 times a -1, because that is the definition of I squared. A negative times a negative is a positive, so the solution will be 36. Here I'm distributing a -2i, so I have -2i, and when I multiply, I get -12I squared, but I squared is equal to a -1, and so when I apply that, I'm going to have -2i plus 12. And then the order that we usually write complex numbers is the real component first, and then the imaginary component second. So again, the distributive property here, it's a binomial times a binomial. So first is 2 times 4. Outside is 2 times 5i. Inside is 3i times 4. And then last will be 15i squared when I multiply those. And so when we simplify this together, here's after all the multiplication. Then when I combine them together, I have 8 plus 22i. So here's my 22i. And I'm going to have 15i squared, but I squared is a -1, so it's 15 times a -1, which means that that flips to a -15. And when I combine 8 minus 15, I get a -7 plus 22i. Okay, so again, once you understand it, it's a very simple thing to do. You can take a look at this one. I'm not going to explain it. You can pause it if you want to. Make sure if you have something like this where it's 15 plus 6i squared, that you understand that it's really 15 plus 6i times 15 plus 6i. And if you FOIL it, you're going to end up getting this. Okay, so just be sure that you FOIL that correctly, and then you could work the problem if you want to stop the video and check your answer there. The last thing that we'll cover is the idea of a conjugate. We're not going to do a whole lot with it here, but you will do a lot with this in Math 110 if you're going to take that. And what is a conjugate? A conjugate is you have two binomials and they're exactly the same except their signs are opposite. One's addition, one's subtraction. Okay, and what happens with a conjugate is the middle terms are going to cancel each other out, because when you do outside, you get plus 5i. When you do inside, you're going to get minus 5i, and those add up to 0. So it effectively wipes out the I. And then the last term will be minus 25i squared, which you have here. So this simplifies to this, but again, I squared is equal to a -1. So it's really 1 plus 25, which is equal to 26. Conjugates will be very useful to get rid of these I terms in problems that you're going to get in 110. Okay. And so here you can check it. I won't go through it, but it's a conjugate, so it's real easy. We know there'll be no middle term, so it's really the first term squared, because 3 times 3, and it'll be minus 4i squared, but the I squared is going to flip the sign in front because I'm multiplying by a -1, so it ends up being 9 plus 4, which is equal to 13. Okay, so pretty simple, just two pretty simple concepts. What is I and what is I squared?